Welcome to this iconic CNC training video. I'm your host, Steve Stevenson. In this video, we're going to look at Autodesk ArtCAM standard and a very interesting function in the software called Bitmap-to-Vector conversion. Now, before we start, let's talk a little bit about bitmaps versus vectors. I'm going to start by opening Google, and as you can see the Google logo in the center of my screen. That, like almost every graphic element that you'd find on the internet or in the print industry, is what we refer to as a bitmap image. A bitmap image, as the name describes, is made of bits of color that are mapped together to create the image that you see. One of the characteristics of a bitmap image is that as you take a bitmap image and enlarge it, it gets more pixelated because the size of those bits basically expand as you increase the size, so you get a very poor looking edge. Most of the graphic design world uses bitmap images because they tend to be low resolution images, and like on my screen here, you tend to be looking at smaller images, so the pixelation doesn't become as noticeable. In the CAD world, which is the world we live in with ArtCAM, we look for vector images or vector graphics. Vectors are very different than bitmaps. If you draw a circle in a CAD software program, and if that circle happened to be an inch in diameter, if you looked closely at the edge of that circle, it would be a perfect circle. If you expanded that circle to be a mile in diameter to an extreme, and looked at the very edge of that circle, you wouldn't see any pixelation. It would still be a perfect circle. So essentially, vectors are just geometry. So circles are circles, squares are squares, lines are lines, and whether you make them larger or smaller, they always stay the same. And ergo the reason that in CAD software we like to work in vectors, because we can create very clean and precise machining lines and get very exact sizing when we're making an object. So the problem that we have is that we want to convert bitmaps to vectors to machine them. Most software programs, most CAD software programs, don't have that function, but ArtCAM is a very, very powerful software program that has the ability to take a bitmap and very easily turn it into a vector. So as you can see, I have Google open, and I use Google for these type of operations because it does give me some information that I find very helpful. So I'm just going to type in the name of my favorite baseball team, the Toronto Blue Jays. And I'm going to type in, as you can see, I've specifically asked for the Toronto Blue Jays logo. So I'm going to go to images, and as you can see, we found 18 million Blue Jay logos on the internet, and we did so in less than 3/4 of a second. So on my screen, I have many Blue Jay logos. First, we're going to look at 3 different criteria. The first is the size of the image, or the pixel count. So as you can see in Google, as I move my cursor over each of these images, it tells me what that size is. So this one is 1200 by 630. This one is 1200 by 948. As a general rule, I don't want anything a little smaller than 300 by 300 pixels. And in this case, all of these meet that criteria. In fact, one of the features that Google has is if you click on Tools, you can see that there's options here to specify exactly what you're looking for. So for example, if I change the size from any size to only large images, now any small images, say smaller than 300 or 400 dots per inch, are not going to show up. So the second criteria that we're looking for is we're looking for something that has solid colors. We don't want to have something that has what we would refer to a gradient or a gradual screen. All of these images across the top row meet all of that criteria. If you come down here a little ways, you'll see this one here that has this change in shading from blue to black. This can be problematic for the software because it doesn't know where to draw the line. Essentially what the software is going to do is it's going to create tracing lines around the image so that we have clean machining lines, and it won't know where to draw those lines. You can see this image here also possesses that same problem. So anything that has that gradient or graduated screen, like this one down here, this one, would be images that you'd want to stay away from. The third criteria that we're looking for is we're trying to avoid anything that has very, very fine or minute detail. If you look at this Creighton Blue Jays logo here in the middle, look at how small the lettering Blue Jays is. You have 2 problems when you're looking at something with fine detail. Number one, when it converts from a bitmap to vector, you may find that these lines aren't nearly as crisp because they're just starting too small. The second problem is, if you can think of a piece of wood, we assume it to be flat, but in fact we know it's not. So if you had a variance in a piece of wood of 4 or 5 thousandths of an inch, which usually isn't very much, you could actually find that if you were machining this word Blue Jays, the B and the L might turn out, the E may not machine at all, and so on, based on how flat the material is, because a CNC machine assumes the material surface to be flat. And we know that's not necessarily always the case. So basically all the ones across the top row meet all of that criteria. So basically we're going to pick the one that we like the best. So I'm going to start with this one here. It's 1200 by 948, so it's nice high resolution. We have no gradient or graduated screen, and there's really no fine detail. There's the trademark logo here, but once I convert it from a bitmap to a vector, I could literally take that trademark logo out, or I could even type it back in using the text tool and put a clean TM in there in replacement. So I'm going to click on it, and you can see there's our image, but one of the common mistakes is that we save it from this point, because I could actually save this image as you see it here. The problem is it's not as described here, 1200 by 948. It's actually a low resolution reproduction of the image that we're looking for. It's basically an icon. We want to click on View Image, and when we do so, the only thing that we should be seeing on our screen is the actual image itself. So I'm going to right click, and I'm going to save this image. I'm just going to save it to my logo, or to my desktop, and as you can see, it's already named Jay's logo, which is exactly what I'd like to call it. And we drop that onto our desktop. Now we're going to open ArtCAM Standard. So now that we've got our image saved, what we want to do is open it so that we can convert it from a bitmap to a vector. So we're going to go over here in ArtCAM Standard. We're going to click on Open, and we're going to scroll down and find our Blue Jays logo, which is right there. Now, as you can see, the software wants to change the size of this image from its current size. It actually is changing it from pixels to millimeters. So it's changing it from 1200 pixels by 948 pixels to 1200 by 948 millimeters. First of all, we want to change it to inches because I want to work in inches. But what I don't want to do is I don't want to modify the size of this, not until I've converted it from a bitmap to a vector. So I'm going to go over to the top left corner, and I'm going to set my origin position in the top left, because we use the top left as our origin with our iconic machines, because that's where the home position is. And very simply click OK. Now, as you can see, as is the case with all of our projects in ArtCAM Standard, we have a 2D view and a 3D view. So I'm going to go over to the 2D view, and we're going to use this tool called Bitmap-to-Vector. Now, as you can see in the Bitmap-to-Vector tool, the first option that we have is to reduce the colors. So currently we have 255 colors, and I'm just going to close this for a second, so if I zoom in, you'll see all of the various shades of red and blue that are in this image. So there's a lot of different colors. And we want to reduce those numbers of colors from 255 to the lowest number that we can get without actually losing a portion of the image. And let me show you what exactly I mean by that. So I'm going to grab this slide bar. I'm going to move it from the right to the left. And I want you to watch the image as well as the color palette on the bottom. Now you see on the color palette, you'll see colors beginning to drop away. And that's because what it's doing is it's combining two colors that are similar, making them a single color. So we get down to 6 colors, and then 5, and then we get down to 4. And you can see things are starting to change pretty quickly. When we hit 3 colors, you can see something happen there that's not good for us, which is we lost that red maple leaf. So we know we can't go back to 3 colors because we're going to lose the red maple leaf. So we're going to stop at 4 and apply this. Now, I'm going to close the Bitmap-to-Vector window because we're not quite done yet. We want to get this down to 2 colors because that's going to give us the best opportunity to get really clean, defined lines, because the software doesn't have to make any decisions then. So I'm going to go up here to Bitmap in the menu bar, and I'm going to pick what's called the flood fill. Now, what the flood fill allows us to do is go down here to the color palette and pick a color that we want. So in this case, I'm going to pick the darkest of the blue, and then we can change anything on the image to that color. So by very simply one click, I can change that red to blue, and now I can put that tool away. I can once again select my selection tool. Let's go back to our Bitmap-to-Vector conversion and continue this process. We'll go back to reduce colors. Taking it from 4 colors, we'll reduce it down to 2. And as you can see, we only have the 2 colors. We can apply that. So the software now doesn't have to make any decisions about where to draw lines because there are only 2 colors to draw lines around. And very simply click on Create Vectors. And as you can see, it created vector lines around the image itself. And if I close this Bitmap-to-Vector tool, I now have vector lines that completely create the Blue Jays logo as you see it. What's really interesting is if you zoom in, you'll see where we used to have pixelation. We've got nice smooth machining lines. What's also interesting is where we have a sharp corner, the software recognizes that and tends to maintain a fairly sharp corner. It's not super sharp, but it's pretty good. So now I'm going to take this entire image, I'm going to right click and copy. And I'm going to close this session of ArtCAM. If you want, you can leave this open and open a new session. ArtCAM allows you to run multiple sessions at a time. But in this case, I've kind of done all the work I need to here. So I'm going to close this. I'm going to open a new model. I'm going to set my material size now based on the project I want to do, which is 12 by 12. Origin point in the top left corner, going to work in inches. And my resolution, again, is going to stay at approximately 1000 by 1000. I'm going to click OK. So there's my workspace. Let's go over to our 2D view. We're going to right-click, and we're going to paste. Now, as you can see, if I zoom out, our image is enormous. But what we can do is now, using our transform tool, we can scale it to fit our project. So let's make the width of this project, or of this logo, say, we'll make the height of the object 10 inches. The width is going to be about 12.5. We're going to apply that. And just by using the F9 key on my keyboard, I will center it. And let's now zoom in and take a look at what we have. And as you can see, all of the vectors are independent of each other. So there's some portion of this that I don't want. For example, the TM, I can just hit my delete key on my keyboard and delete that. Let's zoom back out. I don't want to have this border. Once again, I can just hit the delete key on my keyboard. Now I can drag my mouse over our entire BlueJ logo. And the F9 key, which is the shortcut key to center, is going to center the object. So we've created a very clean vector image from a bitmap. And as you can see, the vectors are very nice and smooth, so it should create nice machining lines. So now it's very simply going to drag our mouse over the entire logo. We're going to go up to Toolpaths. And in our 2D Toolpath section, we're going to use the V-bit carving toolpath because we want to make sure that we retain this square geometry where you've got these nice sharp corners. We want to keep those. Our start depth is going to be 0. We're going to set our maximum tool depth at 1/8 of an inch, so we're not going to machine deeper than that. And we're going to click to select the tool that we want to choose. In this case, I'm going to use a 90-degree V-bit. Scroll a little bit further down. We need to define our material thickness, which we have not done yet. We've defined the X and Y, but not the Z. So there's our material thickness at 3/4 of an inch. Let's calculate it. So then lastly, we're going to run our simulation. And as you can see, there's our image. I can use the roller on my mouse to zoom in just by clicking on the image and rolling the mouse forward and backward. And I can also push the roller down and rotate this on an angle. And if I want to push the left and right mouse button down simultaneously, I can pan it or move it around to a different location. So I could want to zoom in, for example, just on the point of his beak. I can do that. And then lastly, we click back on Toolpaths, and we want to save this toolpath. You can see only one toolpath in this particular project because we just have the one V-bit carving toolpath. I'm going to save it to my desktop. We're going to call it BlueJ. And the post processor, or the machine file format, as ArtCAM refers to it, is called GTEC mm.nc. So if you're using an iconic machine, that's the machine file format that you want to choose. If you're using a different machine other than ours, you'll need to know what the machine file format specifically for your machine is. We're going to click Save. And it's now saved that toolpath. And then the last step for us is, let's just go to our desktop. So here's our BlueJ program right here. We're going to open up iPicture. Now the NC file that we just created will go directly to the iconic machine, but the border function will not work. So if you want to activate your border function, which basically will trace a box around your image to show you the parameters of the machining area, then you need to follow this process. You click on File. You're going to open a G-code file, and from the desktop, you're going to select the bluej.nc file, and very simply just click to confirm the analysis. Okay that it's been totally analyzed, and we'll just save this as exactly the same name, only now it's going to be bluej.gee. And as you can see, it popped up on my desktop there. So now we've basically completed a bitmap-to-vector conversion, posted it out, created a toolpath, and we're ready to machine that project. So that's the completion of this video. Our next video is going to cover importing a 3D model and creating a machining toolpath with it.